Hello, everybody, and welcome to this month's practice group.
Thank you, Beth. Good morning. My name is Mark Drevesky, and there's some faces to the names there, so you guys know who we are. We're joining you from ZGS offices here in Seattle. I'm our Operating Group Quality Director, and with me I have Chris Allen, our Integrated Construction Manager. And as we kind of go through this and talk about how we're utilizing BIM today, you'll get a feel for how the quality department in construction has a vested interest and what the integrated construction coordinators, is what we call them in our office, are doing, and we're working hand in hand. So we can kind of move on to the next slide here. So here's our agenda for this morning, kind of getting the introductions out of the way. Talk a little bit about life cycle and business needs, and more specifically Mortenson's approach and how our business plan and how our strategies align with the VDC world. Talk about integrated planning and then some examples, and then we'll close from there. So just specifically some definitions. I'm sure this is nothing new to you guys, so just so you understand the acronyms when we're talking BIM and VDC, so we're all on the same page. This is what we mean. I don't know about your companies, but Mortenson has an entire dictionary of acronyms internally, and sometimes we throw people off, so I just wanted to make sure that we're all talking about the same thing. Go ahead, Chris.
It's Chris here. Just a brief intro here. You'll see as the slide builds here a timeline of Mortenson's processes related to virtual design and construction over the years. And it's really our philosophy, our approach, that the virtual design and construction processes utilize BIMs, building information models, but the value comes from the process, not necessarily the models themselves. The models are just a means to the end. Here's a little background on some experience over time where we're trying to grow both our project's utilization of virtual design and construction, and then at the same time build the expertise and embed that expertise within our folks' skill sets. Here's a little more history, if you will, or some reference or guideposts as far as Mortenson's progression through virtual design and construction. The area we want to spend the most of our time on today is really acknowledging the difference between, quote, using BIM on a project and differentiating those various uses that apply value through virtual design and construction. That's that acronym again. This reference graphic here is from the Building Smart Alliance, and this was part of a project that Mortenson was a contributor on. Among others, there was a consortium of folks representing architecture, engineering, contractor, and the owner-operate areas of our industry. And this is really the framework that we use to really create a frame of reference for the various uses.
Let me go ahead and just interrupt here real quick if I can. So typically, you can see the plan, design, construction, operate silos, if you will, throughout the duration of an entire project. Historically, the general contractors have been comfortable in our silo there in the third column. This is kind of where we operate, and this is kind of where we feel comfortable, and we take elements from design, we build it, and we typically hand it over to with the keys to the customer, and we move on. That was historically how we were doing it. What we're looking for right now is to leverage opportunities to bleed these lines more, which means we're supporting design and operate elements of the life cycle of a project. Now, what this doesn't mean is we do not want to come in and start designing projects. What we're looking for is opportunities how we can leverage our support through our knowledge and expertise and constructability to support design efforts all the way back to the planning stages, to support efforts to get information into the specifications that would in turn benefit the end user. We're approaching it from the thinking of it in terms of thinking of the user's needs in mind from the beginning of a project. So that's how our strategy is over the last few years has been shifting, and we've been leveraging more and more partnerships with our designers and our customers, talking about this stuff earlier and earlier in the life cycle of a project.
Mm-hmm. One of the notes here is that the key really to success with this that you all have likely experienced too is determining which of these model uses add the most value for a particular project. And you think of these uses as levers or volume buttons that you can turn up and turn down and really enhance a particular use maybe, or if another use is not expected to deliver value, you focus your attention elsewhere. The great thing about this framework really is that it provides some consistent nomenclature, and beyond just doing BIM. That was really a transition, and it's a paradigm shift here within the industry too, that as our firms in the AEC industry and then the owner, definitely the paying customer, get more versed in expectations that we're no longer just, quote, doing BIM. An important piece of this is, like Mark mentioned, is how all the parties contribute or inhibit VDC use to add value on the project. The largest way we believe here is really to improve this is to acknowledge potential downstream uses for BIMs, for the building information models, early in the project. So Mortenson's intent is to support the design and owner team to best deliver the value, and not necessarily be interpreted as, we're trying to define what the owner's needs ought to be. I mean, we're here to participate there and contribute and make sure that those are enabled. Likewise, with the design team, is it our intent to say this is how the designer ought to be using it. The point is here there's a dialogue and the framework really across the whole life cycle.
Okay, so when you're talking about quality in construction and specifically kind of how Mortenson's organized, why VDC to quality? So essentially what we're trying to do with quality is we definitely have to control our cost. We have to mitigate our risk. It's all about customer satisfaction and repeat business. So we'll go on with the next slide here. There we go. So Mortenson's business model, we typically shy away from hard bid work these days. We are more of a negotiated contractor. Our business model is centered around not necessarily achieving work by giving the lowest bid. Ours is targeting specific customers, specific businesses, and specific partners to go on more of a negotiated front. And to do that, to achieve our desired outcome, our target value, most reasonable price, and repeat business, we have to really control how we're delivering our work, and that's where quality steps in. Because if we want, thinking of the terms of the customer and thinking in terms of the end in mind when we're planning a project, we're trying to give the customer the best product for the cheapest price and leave them with the best lasting impression so we can turn around and have either referrals or repeat business. When we, just a couple of stats here, when we do our customer surveys, when we are rated as a far superior contractor, when those particular customers go out and venture out to do additional work, we historically have a 60% chance of getting that work on a non-compete basis when our customer service numbers are high. So that's our strategy, and that's how we are approaching it. So again, the goal is to control the cost, manage risk, and improve the customer experience. And how do we do this? We do this through integrated planning. Integrated planning, and we'll kind of phase into that. We will considering safety, quality, and efficiency. And the VDC processes that we're utilizing and the examples we're going to show you today support that integrated planning effort. So essentially, this is a toolbox of elements that we have to choose from, and we have to decide which tools we're going to use on which particular job as a strategy and move forward from there. So when we say we're going to do BIM, we're just not going to go out and model every job. We're going to identify what specific needs are for the customer and the success to that project and go from there. Okay? So ineffective planning. So I always enjoyed these types of photos. Yeah, go ahead.
Sorry, this is Matt. We just had a question before we get started with that. Mike McVitie was wondering, who within your team at Mortenson maintains the updated BIM for transference at the end to the owner for operational use?
As far as a person, it could vary within a team, but typically each project team has as a part of the team an integrated construction coordinator that is one of our professionals alongside the superintendent, project engineers, project manager, and so forth. But in a lot of cases, even that responsibility is a little blended. I've seen project managers take a leadership role there. In some cases where right from the field, the superintendent is really the one that's the interface of that transition.
Yeah, we typically have a lot of people that are utilizing the model throughout construction, but as in terms of kind of ownership, a champion, if you will, throughout the duration of a project, it's our integrated construction coordinators, and then they may actually be taken off a project and in the 70 to 80% range, and then come back on when we're doing transition to sustainable operations, when we're talking about delivering the model, and the other closeout deliverables the customer might get back into it just to make sure that that process is as smooth as it can possibly be. Does that answer the question out there, I hope?
I think so. Thank you very much, guys.
Okay. So essentially, like I said, our strategy is developed around integrated planning, and integrated meaning it's not just us. We're involving all of our partners, from subcontractor and vendors to the design partners, even customers. So when we don't do that, of course, the schedule can suffer. We can have increased costs, decreased quality, and reputation, and the worst case scenario is when we do ineffective planning, somebody gets hurt in the process, which is absolutely we do not want. Okay, so VDC is helping us be better planners. This is actually a photograph of one of our job site trailers. That's our project manager up there, cruising through the model. We're utilizing a smart board, and you got our project superintendent there on the right and our quality manager on the left. And up in the upper left-hand corner is our ICC coordinator, then our two other project engineers. So this is an internal communication tool that assists us in helping develop better integrated work plans. So of course you can kind of see elements of the improved planning, increasing the predictability. We want to know what's going to happen, when, internally and externally, communication to the outside world, communication to the customers, especially when we're involving either adjacent spaces or disruption avoidance with occupied spaces. We need to know what's going on there. And managing those expectations. And as you'll see in the following slides here, some elements of how we can utilize VDC and leverage it to make that communication clear. Again, beginning with the end in mind, establish a plan, and control the perceptions. Value added. So we're not going to do something just for the sake of doing it. We're going to think in terms of the customer, what their desires are at the end, and utilize that. Okay. As a part of the, how do we do that?
Yeah, this is one of the most important parts. It can be natural from our own perspectives anyway. What we'll see frequently is so many things to pursue on a project, and so many things are important, and there's a natural tendency just to dive in and just start creating content and moving. You know, the feeling of let's just start putting work into place. Well, really the strategy here that's important is to make sure that we're pairing up those opportunities, needs, and risks for a particular project, align a use to make sure that we realize the opportunities on the project's behalf, or we mitigate risks, uncertainty, and so on. And these model uses really achieve that. That's really the key objective. So there's definitely an art to this process. The framework and the graphics may show this nice schematic view, but really it's the dialogue with the team and reviewing what those particular project needs are. Here's an example of, again, this is one of the Building Smart Alliance templates. If the folks on the call are not familiar with it, I definitely encourage this. This is open source information from that consortium that we were talking about that really we think gives the best shot at leveraging common nomenclature for various uses and aligning a particular project's needs with these uses. So all the way from the operate stage, from construct, design, and plan, really beginning with the end in mind, what would the client, most downstream customer, achieve value from? Okay.
And this is a really great tool, not just for us, but it could be a really great tool for specification writers when we're thinking about in terms of interface with customers and trying to interpret what they want in the end, and trying to outline that so we can set the expectations up early in the design phase and get those written into the specifications. The earlier the better, as we'll find out here in a minute.
The next step after you've established these potential uses really is creating a plan that the team can utilize to agree on and go execute. So there's definitely an element of model management between the various firms, designers, trade partners, the GC, CM, And the key thing that's happening here is we're establishing roles and responsibilities, schedules, milestones, all of the intricacies that have to do with model handoff and right of reliance. Those sorts of things ought to be established or determined and then established and documented within a plan.
Yeah, so it needs to be very clear on who's going to make the model, how that's going to be handed off, who's going to manage the subcontractors with their input, how we're going to do clash detection, how that's going to be delivered back to the architects, who's as-builting, and who's delivering the final deliverable back to the customer. So what this document does is basically, for all the parties involved, makes that crystal clear from day one. So we're not having these discussions as we go through on who's doing what. Okay, integrated planning. So what you're looking at here is a phase plan. This is a structural phase plan for a project that we did in Billings. So this is typically how, if you guys have ever heard the term the last 100 feet, when we start to take this information from the model and actually deliver it to the foreman and the craft out on site, we translate this information down to, this is a PDF, and it was actually an active PDF where we had a movie in there that showed our construction sequence, but it was very critical because we had some very critical leave-out elements to be able to get mechanical equipment into the building. So we utilize this format to actually communicate that. So then it's also we're able to print this out in an 11 by 17 format that the foreman can take out and keep in his gang box so he understands or she understands what's going on and can communicate that to the craft on a daily basis. So we cover safety and quality and, of course, sequence. And we utilize this information. This is extracted right out of the model. And I think we utilize Synchro along with this structural model so we can show the sequence of how this is going up. And we, like I said, we're able to embed this into a PDF element so we can email this to everyone and they can actually play it at their own leisure and actually see what was going on here. Other elements typically in here, you know, who the players are, their phone numbers, other related plans associated with this, and that's it. And then we've also begun to incorporate 4D planning, and this is extremely critical on this particular project. You're looking at 3 clarifiers, 3 existing clarifiers, and a new clarifier for a wastewater treatment plant that we're installing up in Bellingham, Washington. The purple circle that you see there is actually a 100-foot radius from a heron's nest. Now, in order for this project to permit, we basically could not be performing any construction activities within that 100-foot radius between the months of January and April, which is the heron mating season. So we had to basically prove how we were going to get this done, maintain our schedule that the customer's needs, and be able to permit it through Department of Ecology to be able to show that we weren't going to do that. So for those of you that know anything about clarifier mechanisms, typically you construct them from the beginning or from the center and you work your way out. So the model that you see on the left is actually how the clarifier was originally planned in the CPM. The model on the right is how we had to adjust it to build the elements that are within that radius first and work our way back. So there was a lot of sequencing and replanning to make sure that we were not within that 100-foot radius. So this was a communication tool. So we used BIM to leverage this with our project teams, our subcontractor partners, the owners, and the city to show them that we would get this done in the time frame allotted, so we're not within that 100-foot radius come January. Otherwise, we would have never permitted. Okay.
Another use and application of the intelligence and information that's contained within a BIM is its basis for cost estimating, also known as 5D. So the common nomenclature, of course, with 3D, the spatial attributes of a model element, and the 4th dimension, as Mark just mentioned, is adding the element of time and sequence, and then the 5th being cost estimating. Here you see an example of model elements that are linked to cost assemblies, and model assemblies and cost assemblies together can be used to really be used as the vehicle, kind of the carrier for cost-related data. Existing conditions modeling is one of the uses that was right at the very beginning that of the kind of the time scale or the life cycle here. So you can see an example of an existing facility and build out, and the coordination that goes with the proposed design also through laser scanning.
and let me just make a couple points on this. This is extremely important because as kind of the economy shifts, especially with our customers in the medical field, the late 2007, 2008, the model was let's build very large facilities and let's bring people in. But now as the economy shifts, you think of in terms of scale, we're going into a lot of existing facilities and reconfiguring them. So this seems to be the business model now that's pretty typical for the medical industry right now. So the ability to be able to go in there to an existing facility that might be functioning above or below you, identify the existing utilities and design around that is actually incredibly critical to the schedule of the project. Otherwise, we have to identify where things are so we can design around them in order to maintain that schedule. So this technology is invaluable for that.
Here's an example of the graphic output that would come from existing conditions modeling and capturing the existing conditions within in a space that this is a renovation example here, and the color that the gradation that you're seeing here in the graphic is demonstrating the variation in the elevation of the floor slab, and you can see superimposed there the floor plan on top of the grades there of color. And the main takeaway here is that basically the bright green hues in this display were the design 0 for the particular floor. And what you see represented here is the variation of over 2.5, I think it's close to 3 inches total variation within this floor that by the naked eye you wouldn't necessarily see, but by capturing those conditions, you can really address and determine where you need to address some common construction tolerance in an existing facility. So this particular area here, you can see telegraphing through the existing floor slab, the structure. So you can see where deflection has come into play here, and the blue would be lower, red higher than the design floor elevation.
So, and in thinking in terms of managing expectations, our surveyor went in and was able to, he took about 600 shots to develop this. But as far as managing expectations and then driving efficiency and quality, we saw right off the get-go that we were plus or minus 2 inches in a span of 10 feet in some directions. So this particular build-out, we actually had C-channel metal base that went around the facility. So you can imagine if we had a 2-foot gradation in 10 or 12 feet with a C-channel base, that would stick out pretty dramatically. So we were able to go in and level the floor accordingly before any walls went up. So when we put those walls down, we were dead on there. So again, this tool helped us manage those expectations because by going in there before all the walls are completed, we were able to basically do a super flat floor, just kind of brought in the skim coat there and just mopped it through without having to worry about getting it all up on the walls and everything and discovering it after the fact. So, and this only took, I think, just a couple of hours of walking around and taking this point in, pouring in, and boom, and knew exactly where we were. So, extremely valuable tool.
This allows you, we were making the example of where to turn up or turn down a process here. It allows you to be very strategic, too. If you've got an area that's high or low, and it's at a critical area, reception desk, or like Mark mentioned, intersection of many walls, versus maybe an open area where you've got a little more tolerance to avoid having to go through the expense and time to either bush a floor or fill. It helps us make better decisions. Another example of better planning that goes with it.
Target where you're going to spend your money.
Yep. This next example is this is definitely a construction use. That Mortenson, being a self-performed concrete contractor, among other things, but this specific use pertains mostly to the self-performed concrete work, where you've got on the lower right of this diagram, again, it's an electronic document, PDF that can either be printed, can be taken on an iPad, exchanged electronically, and leveraging all of those advantages. It's model-based, and then we've marked up in one document the various, say, penetrations, dimensions, embedded items structurally or for any other building service, all in one spot. And so you'll see how this spins off some other planning benefits as we go.
So essentially we have a fully coordinated lift drawing for the foreman to utilize out in the field. So we just extract that information right out of the model, put it into a format that they can readily understand, and we can easily do QC off of it and build from there.
Here's an example set of metrics. Mark, I don't know if you'd like to speak to this, but over 800 embeds on this project as the courthouse and buildings, and inspections and corrections via the model in a process using the virtual building model enabled us to achieve 99.9% accuracy.
So out of 811 embeds on this project, we got 810 of them correct. And we just missed one because it was misplaced twice, and we didn't do our follow-up inspection twice like we should have. It was in the wrong spot. But we modeled every embed on this project because we figured out that the total impact, if we got one of them wrong, would be approximately 7 days of disruption of the sequence of the steel erection in that particular area, which would have disrupted the schedule completely. So we had to know with 100% confidence every single embed on that job that was in the right spot, because if not, we had to RFI it, we had to stop, we had to RFI it, get it fixed, order the materials, make the adjustments to the steel beam, and then turn it back around and get back in sequence. The total disruption for each one of those elements was 7 days to the schedule. So you can imagine real quickly if we just missed 4 of them, all of a sudden we lost a month, which we did not have. So it was absolutely critical to get that right.
Hey guys.
Yeah, go ahead.
Keep going. I have one comment from Michael White just saying that it was really great to see the floor side elevation image that you had put up there. But then additionally, Brian Lightheart has a question. Was the CIP drawing example developed for a base model provided by designers or a model built wholly by Mortenson?
It was based on design model content, but given the level of detail that we need to show in the model, because our drawings for placement are at a higher level of detail than the design model in this particular example. But that transition can be coordinated, and we've seen that happen at various points. But in this particular example, I can give you just a topic that's pretty frequent there. Maybe the design model shows a slab that's flat in the model. The model content is completely level or flat, level. And in reality, in the contract documents, it could be noted to have a 2% slope, with an arrow showing directionally where the slope goes to a floor drain or what have you. Those elements are commonly not modeled with that slope in the design model at a level of detail, say 300. If you follow the kind of the AIA level of development scale model progression specifications. So the team has to, as a part of the execution planning process, the first step was we determined that there was a use and a value for coordinating concrete placement. And so this lift drawing, electronic lift drawing coordination process was enacted, right? So we proceeded there. The next thing was, great, where is the model content coming from? And to what extent can we rely on design model content? And then if we can or cannot, do we enhance or completely need to recreate content to rely on it? And there is a mix. There isn't a one single answer that serves all every project. But I hope that answers the question as far as where that came from.
Sure. Thank you, guys.
Yeah. So essentially, we did not develop the original structural model here, but when we got a hold of it, and then we took ownership of the clash detection and coordination process. So we got all of our models from our mechanical contractors and our electrical contractors, and our critical penetrations were basically reconfigured around clash detection results, and then here we have the end result. So. So this is the fully coordinated effort, and essentially, to be honest with you guys, our foremen don't build off of standard typical lift drawings anymore. They demand these. They will not proceed with formwork installation until they have this in hand.
You could think of it as 3D comprehensive shop drawings, that instead of looking at individual shop drawings from, say, miscellaneous metals provider, structural steel for embeds, a separate, perhaps precast set of shop drawings, we're trying to integrate all of that information, be able to evaluate it in one spot, and then take it to the field. And so you've got one source of information that's been validated, it's already been checked, has become for construction use, and put the work into place right the first time.
Okay.
Okay, we spoke to
Yep.
this. Yep. This is an extension almost of what I was just saying from a structural example on the 3D shop drawing concept. You can get into something that's very specific as far as interior build out and much more kind of soft, if you will, or as a part of the finishes. So just as vital, dimensions or finishes, in particular a head wall within a medical application, that same tolerance or the benefit of really planning and coordinating the placement of items enables further additional value to come from prefabrication, increased quality and productivity that reduces the cost of putting the total work in place. So you see that example here.
And I'm sure several of you out there in phone land here have built a hospital and have done patient room mock-ups before and have been involved with all of the doctors and nurses and all the parties affiliated with this, making decisions on where things go. So we knew we were going into this facility that we were going to do a physical mock-up. But first we started the virtual mock-up. We gave everybody 2 or 3 passes on the virtual mock-up, moved things around before we spent time building the physical constructive mock-up. Then once we established that, then they came in and did their final iterations. But it saved us a lot of time and hassle by quickly being able to make adjustments. Like you can see down there in the bottom left-hand corner, the head wall and the med gases and all the critical elements there you would find behind the head wall or behind the bed there, putting those to the dimensions where they think they want them, and then making the final fine-tuning when we had the physical mock-up in place. So that saved us a lot of time and effort there.
I have a question. One of the things that we've run into with this from the design side is how do you deal with construction tolerance and still get the outlets in the right place in the casework? So not translating the out of tolerance or variability of the concrete floor so that all of them line up when the studs are placed on it. So how does that tolerance get addressed?
Well, in terms of like a floor elevation, we'll pull all of our elevations from the ceiling, to get everything to line up, and then we'll have tolerances in the floor. So if it's an existing facility or a new facility where you have deflection, we can come in a level later. But we set all of our elevations off of the ceiling, set a common line, so then we're always consistent. So then at the floor base, we might be a little bit up or down, but as far as the critical elements and being all in line, those maintain that elevation.
It is an advantage, though, that you can go through and vet out where you may have additive tolerance situations. It's good luck when they cancel each other out, but you have to factor in when tolerance or the lack of it grows, and all of a sudden you've got compounding maybe trades or, as you mentioned there, that dimensionally you could not align all of a sudden.
I think we have an example of that coming up here on the spray foam.
Yep. This particular model use is it's called 3D control and planning, and the concept here is you've got model content that originates from a design model, perhaps, and it also could be enhanced to construction level of development as well. But the point in the graphic here that you see here is you've got model content that's created, point data for field survey and layout that really translates to an ID, a certain point you're trying to lay out, whether it be the corner of a wall or a footing or an offset off of the grid line, for example. And you translate that X, Y, and Z information from the model, manage that point data, and push it to instruments that are set up to lay out that point and those coordinates in the field, and then also retrieve existing or as-built conditions as you go. So it's very iterative. Really, the graphic kind of simplifies here the loop, but this loop is really playing out many times a day by our field surveyor that's shown in about the 7 o'clock position here, where he's both retrieving information and he's also pushing it out too. And the loop is kind of endless, and it's used for both layout of work prior to placing work, while it's in progress, and then as it's completed before we go to the next stage. So in the example you see here, he's working on subgrade, and layout had been done previously just to get to those cast in place piers that you see there. So
in terms of quality and productivity, again, a vested interest that I would have in there is we have an established model, and we're utilizing a software called Get the Point. Essentially what that does, like Chris mentioned, goes in there and identifies points based on change in direction or elevations of a structural model, imports that directly into a spreadsheet which gets translated to the transit there. So in terms of productivity, a typical two-man survey crew will be able to take 200 to 300 shots a day with a standard transit and a stick. With this method, we're able to have one surveyor take up to 700 to 800 points a day with a single person, and the accuracy is pretty much with 100% accuracy. So as the ability to be able to take all of those shots of formwork in place and make sure we are where we're supposed to be and where all of our penetrations are where they're supposed to be, we can do that almost 3 times as fast with half the crew utilizing this technology.
This next example, you can see the gentleman there, the carpenter foreman, Brad. This would be an example of some of the output as he's in collecting the subgrade variation. So it's not only work that's complete, as I mentioned, it's while it's in progress, and you can see a graphic here demonstrating.
Yeah, this is a cap break for a clarifier mechanism, and again, this is putting it in a format that can be easily communicated. So again, you're looking at 0 being the green, the lows being the blue, and the highs being the red. This is a printout image that we can hand directly to an earthwork contractor, and he can understand where he's high and low right away without having to completely explain it. So he can go in there and they can level that out, and we can take a few more shots, and you can take the shots wherever you want. It's not a standard grade. You can walk around and just take them, and then we can have an output within a few minutes again to see if we're where we're supposed to be. And again, why is this critical? Well, clarifier mechanisms that are filled with typically millions of gallons of water, if our slab is too thin in an area, we can have a failure. So it's absolutely critical we get that right.
Here's an example of an overlay of 3D coordination. One of the very first, when folks were beginning to apply BIMs to benefit their workflow, basic 3D coordination is still one of the highest areas of delivering the most value on a project. If you don't get it right, then you really pay in many other places. But combined with overhead 3D coordination, this is the Everett Hospital Tower, Providence, that you've got coordination also in wall and overhead support, and by system you can identify, manage, and really make sure everything fits together nicely.
Mm-hmm. Yeah, and clash detection, I'm sure most of you guys have realized pretty much has paid for itself right off the get-go. So this is a pretty standard staple on our projects, even the smaller ones that are under $5 billion. We're still utilizing this technology because it can be done quickly and effectively. And again, it'll with 2 or 3 conflicts out in the field, this can pay for itself.
With some of the design team on the call here, for sure, this slide shows a progression of how we've many times been able to apply the virtual building mock-up as a successful path in the progression from virtual construction, and you manage it virtually to begin with, create a physical mock-up that is further reviewed and approved, and then finally you place the work.
So Beth, earlier you were asking about tolerances. This is a pretty good example here. Again, this is our Billings project, and what you're looking at on the left is a model. You can see the structural steel. Then we modeled the fireproofing that would go over the top of that. And the enclosure system on this building was a combination of rigid insulation and spray foam to be the air and vapor barrier on the backside of the precast. Well, the spray foam has to be a specific thickness. And when we're thinking in terms of the detail that where we're right up against between the I-beam, the fireproofing on top, and the thicknesses of the spray foam, the thickness of the spray foam that it had to be to maintain our R value requirements, we determined with the tolerances in mind with the precast was not going to work. So we had to change to the rigid insulation detail at those locations, and that's what you can see in the picture on the far right-hand corner up there. So we actually went in ahead of time. We're able to figure that out utilizing this technology where we would have these tolerance conflicts and change the insulation detail in those specific areas. Because again, being this in Billings, if we don't have the right R value, we have cold spots, it's very evident in the product for the end user because it gets pretty cold there.
summary as we kind of button up the 3D shop drawing review process. This is essential for review both up front with the end user, who often may not be able to interpret 2D plans, elevations, sections, and so on. And this in combination with walkthroughs, virtual walkthroughs, and then finally perhaps a build out of a mock-up unit. Just another example of that. This is the graphic represents a workflow in kind of one of the final uses of virtual building model information and intelligence by the facilities management folks, the actual building owner. And there are many ways to integrate the building data and information that comes from the design and construction model. That would include the trade partners. And probably the biggest takeaway here, though, is that dialogue is essential to really establish with the owner what their value is expected from utilizing model-based information there. Because in many cases they aren't set up to access the model, whether it be a technology barrier or whether it be training or the right personnel, or maybe it's just existing facilities that aren't leveraging it already, and it's just it's a consistency issue more than it is anything in some cases, where maybe other buildings or parts of a complex or institution are paper-based or 2D document electronic-based. And so finding that intersection to be able to hand off and then manage the data, that's definitely a dialogue that has to happen between owner, design team, contractor to get it right.
So what we've discovered with this process, that now it's becoming possible. What we're running into, and I'm sure many of you are aware of, okay, so facilities owners actually seeing the value in a model, what I call a smart model, that's loaded with all the equipment, all the operation, preventative maintenance, tasking, location, everything for every component that's out there. So of all the times that we've transmitted the as-built model over to the customers, are any of them utilizing right now specifically for operations? No, they're not. What they're utilizing the model for right now is for training and presentation purposes. But we're going in that direction. Every year we're seeing this become, it's becoming easier and easier to impregnate all this information into the model, so we see the industry going there. And the big jump here is being able to have the CMMS systems, the Maximos or the Archiboxes of the world begin to talk to these. So that's a big, huge hurdle in the industry that we're starting to overcome right now. Once that process becomes a little bit cleaner, I can see this probably as facilities operators become more savvy. You get the people out there, the naysayers, kind of retiring out of it. This is the way I've been doing it for 50 years. I don't need to change this. This is what you run into in the operations world a lot. The more savvy people come and the new tools they're utilizing with the iPads and the phones and being able to execute PM tasking, utilizing information from the model directly, and kind of take that old work order process out of it, the paperwork out of it. We'll see this become more and more consistent in the industry. But I'm glad to see that we're pushing the envelope, because that's kind of where it's going. Was that? Is that a question? Okay.
We didn't want to omit one of the basic examples of communication and the outcome from a model, and really trying to illustrate what the plan is for work and how it might affect other folks, and whether you're in an existing facility or a new construction environment, the communication is vital there. So there's some great examples from the Seattle Seawall project that we're conveying to stakeholders and business owners and so on, the plan for the work and what it entails.
Yeah, so what you're looking at, the Seattle Seawall, the rendering on the left is actually done in SketchUp, but we imported elements from Revit for the seawall components of it, and on the right you can see the grout-driven piles. And the reason this is so important, and to get these kind of realistic-looking images to the people here, so we got the stakeholders. All of the businesses that run along the Seattle Seawall are going to remain open during the new construction of the seawall. They are scared to death about disruption and people not being able to access their facilities during the construction period. So we're utilizing a lot of these models. First of all, we utilized it to get the project, because we're able to show what our plan was. Second, we're able to show it to these businesses so they can have a much better understanding of what's going to be going on around them, under them, and give them the confidence they need that, yes, we will be able to maintain pedestrian access throughout the duration of this project. So it was extremely critical for one, to get the project in the first place with the city, and then two, to keep the public interest at a comfort level where they should be.
The same communication applies also with our field folks. So Mark mentioned the last 100 feet. It's really an objective of Mortenson to make sure that we've got the right level of detail in the model, and also that it's accessible in the right way so that our folks in the field can apply to deliver the value, and that we don't fall short on transferring that knowledge to the field. Worst thing that can happen is you've gone through the steps to create a great plan and you fall short because you're not able to communicate with the folks that need the information. So, good examples.
Yeah, this is a really good success story. Again, as far as you think maybe the guys on the field would be shying away from this or wouldn't be savvy to it. So we actually brought our computers out into the field, into these kind of weather-tight boxes you can see on the right with a printer and a monitor. And believe it or not, the foremen that were out there really took to this and ran with it. And it didn't take them long to be able to start doing fly-throughs and then go to 2Ds and print images of coordinated documents or as-built documents real-time, updated with the RFIs or the shop drawings. And then again, for our engineers to go out there and do the inspections for the in-wall and above ceiling prior to closure, utilizing this information into the field instead of bringing 10 rolls of drawings with them out there. So again, that's improved our efficiency and our accuracy out in the field.
Here's an example here of the building owner and accessing information that originated in a model and tailoring it in a way that was useful to them and the building engineer folks that could apply the downstream information intelligence. So in-wall photos were linked to 2D PDFs in this case, and this is a touchscreen monitor with a computer capable of showing both model and any other, of course, electronic documents. But the team here scanned existing as-built drawings for unrelated work, but connected or adjacent work, linked drawings to in-wall photos, so that not only do you have an as-built model of a particular, say, copper line in a wall, but you've got a photo to go with it.
Again, thinking with the end in mind, what was the most important to Tim Heidebaugh, this is out of Central Washington Hospital in Wenatchee, what was the most important for him is to understand what's going on inside his walls, because again, those of you that built a hospital know that there's, before the drywall goes on, it's very difficult to see from one room to the next because of all the med gas lines and water lines that go through there. So having photo documentation that's linked right into the model that he and his crews can find easily was the most important thing to him. So that's what we made it turn into a deliverable.
Here's an example of training videos for the facilities management team as well.
Okay, first-time quality, again, why it's so important. We're utilizing all of these tools that we've looked at to get it right the first time in terms of impact to the project, why that's so fundamental. Getting it right, of course, delivering target value for the best price. If we're in there in the first-time quality, we're able to deliver the best product to the customer for the most reasonable amount of price. If our quality issues increase, we have event management in there. That's our inspection process, so that's essentially tracking our deficiency list. That's a trailing indicator that, the cost and time associated with making corrections second goes up. During punch list, the goal, of course, is to eliminate punch list. But again, the more of those issues that pop up in that third level, away from first-time quality, again, the impacts increase, the cost increases, the time increases. But with punch list, you're talking about the design team and the owner team stakeholders in that process, and you're wasting their time if we're developing these tens of thousands of items on a punch list when they should be zero. And then again, of course, when you get into the warranty, the end users utilizing the facility, the impacts are most severe if we don't get it right the first time. If something comes back to haunt us, whether in terms of a leak or something failing or not meeting performance requirements that we should have hopefully determined through the inspection process, again, those tools enhance that. And you can see that here on a scale of cost and time. And if we find these issues in the design phase, when we're doing the coordination, the cost detection, of course, the cost and time associated with them is minimized. As you get into the construction, closeout and during the warranty phases, the cost and time associated with making revisions increases exponentially. So it's extremely important to capture it utilizing these tools early as we can in the process. And again, thinking with the end in mind, thinking of the next project in mind, thinking of that happy customer, again, consistent with our business model. We're not out there to hard bid world. We're out there to develop relationships with customers and develop a repeat business with not only our customer, with our facility partners, but our design partners as well. So again, planning begins with the end in mind. So if we have the right tools and we execute properly, we make for a much smoother project, and that sets us up for the next one. It's all about getting the next job.
Folks, we can take some questions now. If there are any other additional questions, that completes our presentation here.
All right. Well, we have a few questions here for you. One of them just clarifying. Sheldon was wondering if maybe he missed it throughout the presentation, but have you been using architects' models, or have you been creating your own models from the prints?
We do both. And in certain areas of a project, where we acknowledge that there's an opportunity or a risk that we're trying to either keep from happening in the case of a risk, or mitigate, or the opportunity side, we're trying to make sure that we realize the opportunity. There's definitely a conversation that we have with the design team, and let's just say that we'll never turn away design model content, and we'll take as much as, the more the better. There's always kind of a fine line between the level of development that we talked about, the right of reliance on information that's contained within a model, and frequently, you can just, through experience, that sitting down with the team and just determining which items in the model, in the design model, can you, quote, take to the bank, whether it's a certain set of wall assemblies, or early on in the project, if we can determine that the structural model will, you see a 12-inch wall in a structural model, then you can take it to the bank, that there's some certainty with the documents that go with it. But there's always interpretation also, and in the case where 2D documents prevail, the onus is really on the builder to make sure that we're providing and we're going through a planning process, whether it's 3D or 2D based for shop drawing review, and part of our workflow, where you vet out the potential discrepancies between a design model and what's actually, say, means and methods type level of detail.
And I would say what happens a lot is typically if we're going to receive a model from a design partner, we'll take that and then we will analyze it and go into further detail based on risk, like you were saying earlier. If we needed to really focus on one particular element, we'll take that existing model and use that as our baseline and develop it further, and then translate that back around into the as-built to go back. So it's kind of it's a factor of risk and what elements we really need to see and be 100% sure of, or if it's a structural layout with columns and beams, well, we can pretty much import that with confidence. It is what it is, and we'll build around it. So,
an example could be an interior partitions model elements that represent interior partitions, an assembly, a family in Revit, if you will, or a library, maybe another design authoring applications. So if the build team and the design team can sit down together up front and agree on what parameters would be used, and we found a lot of success in just having that initial conversation, because it's something for something. So if the design team is utilizing not just generic wall elements, but a specific wall family that represents a given wall type, that maybe the return on that is faster turnaround or interpretation of cost. So if we've got maybe 3 scenarios for wall configurations, that if we jointly agree to rely on the model for these given areas or assemblies, then it's completely fair to say you could go the assembly 1 foot over, kind of in the model or in physical space, and you may not be able to rely on the same level of detail there. It could be a placeholder element, but just by having the conversation up front, you can establish pretty easily where we can jointly rely on the model for mutual use. Does anyone have examples of that would be on the call where that's worked, or maybe where it hasn't? Those would be good things to talk about, probably.
Okay, well, we have a few more questions as we get here to the end of the time period. Chuck Graham was wondering, what does the role of BIM play in this that can't be done with other models? I know it's kind of a big question, but see if you have some information there.
So the question again stated was, what role does BIM play?
What role does BIM play that cannot be done by other models?
Well, the word model could mean a lot of things, but it's typically just a representation of geometry and spatial characteristics, and carries with it other information, whether it be assembly numbers or spec data, or maybe it's just to result in the 2D contract documents as far as the design team goes. So
I guess I'm kind of a little confused. Maybe on the question, do we need to clarify, is it in terms of software? Like, why would we use Revit in terms of like a 3D studio or a SketchUp? I'm not sure.
And I think in relation to where I've run into that question is with the specifications and other data, is all of this you could do without building information model, with enough planning, but it would take an eternity. And so it's possible without BIM to do the math and make it all work, but it takes so long that it's cost prohibitive.
And let's face it, folks, I mean, 16, 17 years ago, and when we're looking at fees for construction in the 8 to 10% range, well, now we're bidding on jobs where it's 1.5%, 1%, or even 1%, under 1% fee. So the market's changed significantly. We can't afford to get it wrong. We have to deliver. The schedules are becoming smaller, almost 30% smaller in some cases over the last 15 to 18 years. So we cannot afford to get it wrong. So we've just made this as a business model for us that we have to utilize this technology to leverage it wherever we can. Again, it comes down to getting it done right the first time. So could we build it in the past without the models? Yes, we could. Did we make a lot of changes and have to go back on a lot of things? Yes, we did. And we kind of had that built in before, but now we don't. We have to take it away. So we have to figure out a way to mitigate that. Otherwise, if we want to be successful.
And Chuck is responding here. He was just indicating that the presentation was unclear as how, I guess, your specific element of BIM helped as opposed to something like Autodesk architecture, which I know Autodesk architecture was kind of the in-between software package between AutoCAD and Revit. So I'm not sure if there's any more you want to add to that, or we do have a few additional questions that we have asked from the audience as well.
Yeah. Probably the largest differentiator from a 2D-based CAD, if you will, and maybe something that was up to parametric modeling software, whether it's Revit, ArchiCAD, Bentley. The parametric design tools have the ability to carry with them other attributes. So you take a wall, and maybe it's a given assembly, it's 10 feet tall. You're placing elements that are representative of the wall, as opposed to lines that represent the outer face of a wall or a door swing or what have you. So it just is the ability. It's not that it's wrong or you couldn't do it. Just like Beth said, it's kind of a larger bucket to carry with other information, spatial or what have you, cost, like we mentioned, survey data for the field, or even owner-operate type of information. Did you have anything else that you'd add, Beth, from a design point of view?
No, it's just a lot of it's just how effectively you can get all the information linked together. And can all the information exist without it? Yes, but linking it together is the thing that allows us to have fewer copies of the same information.
And I think that actually goes into the next question we have here. Do you all use the GVCA/AIA consensus documents and protocol for managing the BIM model's responsibilities, or do you have maybe an internal document that you use to govern those elements?
That's a great question. The strategy we use is the Building Smart Alliance Building Information Model Execution Plan. So I had an example of this here. So that is the document that we use. See if I can show it. Well, I guess I'm having trouble getting back onto the that particular slide, but the point is that the consensus docs agreement, the AIA E202, the Building Smart Alliance BIM execution plan template, they all carry similar characteristics, but the short answer to that is that when you use consensus docs as an overall agreement, it fits nicely. The consensus docs BIM addendum as a contract vehicle is very helpful. In other ways, where AIA documents are used for the basis of the contract and specifications, we found it to be more reasonable to stay with that particular contract package. So we'll use the AIA E202, but the items that are within each agreement, if you set them side by side, are very similar. You have parties listed, you've got responsibilities, you've got model handoffs are a particular, that's one of the largest areas of concern with it, to really leverage that. So yes, but it depends if on some other things, on if that, in our opinion, if that's the right way to go. Consensus docs are another way.
All righty, we have another question here from David. You're using coordinated are you using coordinated documents such as your steel embeds in the field? Question is, do you submit the design team traditional shop drawings of a limited scope, or after you combine into a composite installation document?
I think it's a little of all of those. It definitely is the last one, where it's a comprehensive design document. I shouldn't say design, it's a construction-generated document, but it is we look at it like it's a 3D shop drawing. It follows a very similar review, except it's enhanced with the benefit of some 3D capabilities. The parametric modeling that we mentioned, carrying a pipe sleeve with the pipe, also with its layout information.
And I think it also depends on the sophistication of the vendor that we're working with. From our steel suppliers, if they have the sophistication to actually utilize this technology and put it in the 3D shop drawing format, and if the engineer is happy with that, then we'll go that route. Otherwise, it'll be the traditional 2D drawings, get it approved, and then we build it into the model, which is what I would say we do about 50 to 60% of the time right now still.
I remember a win that could be a good example of this, where the shop drawing review process, it was for fire sprinkler review, and the engineer of record wanted to review coordination and sizing and so on. So they were attending remotely big room meetings, if you will, and we call that, where you get the various stakeholders involved, either in person, ideally co-located, or just to leverage if they're in another state or the other end of the country or world in a go-to-meeting or go-to-webinar environment. Anyway, the engineer, even though the requirements were such that we would submit 2D documents, we certainly complied, but everything that we did to create those documents was 3D based, even the review. So the 2D review was a formality, really. The review had happened. The designer was confident in the quality of the background, from all the conversations, and established enough reliability, really, credibility with it, that he wanted to see the model as a part of the submittal review, and the electronic documents in 2D were just the vehicle to take the stamp, if you think of it that way. So you're dotting the I's and crossing the T's and closing back around on the contract requirements, but from a productivity point of view, it was 3D based.
Tell you where I'd love to see this go is eliminate the shop drawing submittal process entirely, and have all of the information just embedded in the model, and with electronic signatures on wherever the elements may be. That way, all your O&Ms, everything's just built right into it. Someday, folks, we're going that direction. I would love to see submittals just go away. You know, the model is what it is.
Alrighty, and then if you
I
wrap
think
up
we're
here,
at 10 after, so do you have a last question?
we do. We have one last question here. Is have you ever have your clients ever requested use of 4D BIM for use in owner-controlled insurance programs?
We certainly have owner-controlled insurance programs, and we would apply with it, but I don't think I could specifically think of an example where, because of the owner-controlled insurance program, the owner required a 4D simulation. But they certainly would have received the benefit, and even projects that don't also. But to the person who asked the question, to their point, it's definitely a way to evaluate and connect visually the linkage between schedule logic that shows up in a conventional Gantt schedule and what it actually means to a sequence, the build in the field.
Yeah, we've definitely communicated to those parties, but it's never been a requirement to communicate it via 4D. But we certainly, if we have it, we certainly utilize it, you know, especially on all of our larger projects. We're talking in terms of risk of what's going on around you. Yeah, absolutely, but it's not, I've never seen it specified like you have to have it. Yeah.
Mm-hmm. Great question.
If this presentation sparked any interest on things you would like to see more of, whether it's the Building Smart Alliance, Building Information Model Execution Plan, or modeling existing conditions, or AIA's level of detail, those kinds of things that sparked your interest and you want to know more about them, this is a vehicle to say, hey, I want to know about this, and we can use the larger group of CSI to say, hey, come tell us about this, and we can share it across the country. So give us an email if there's anything you want to see. And thank you much, and have a good day.